Hi everyone, I am now Zhen. In this video, I'm going to share about my final year project, which is titled A Web Portal for Healthcare Services. This project is done under the supervision of Dr. Zhen. Here is an overview of this video. I will start by sharing the introduction, followed by the requirements and design, the implementation demo, and lastly the conclusion. Without further ado, let me start with the introduction. Aging population in Singapore is increasing rapidly. It is estimated that by 2030, 1 in 4 citizens will be aged 65 and above. According to the Ministry of Health, 10% of these elderly are living alone or by themselves. There's no one looking after them, and in the case of emergency, help always arrives late. Hence, the objective of this project is to develop an application which allows the caregivers to monitor the activities of the senior at home, as well as planning their upcoming events, such as annual medical checkup, as well as interacting with them through the memory function. In this project, an administration portal will also be developed to allow the admins to visualize the sensor data, as well as viewing the interaction between the senior and the caregiver. Now I will share about the requirements and design of this system. Here's the use case diagram of the application. As you can see, there are 4 main characters interacting with the system, namely senior, caregiver, admin, and sensor. The senior and caregiver both have the same set of actions, except that only a senior can create a new caregiver. The admin can view the interactions between the senior and caregivers, as well as visualize the sensor data. The timeline record at the bottom of the use case diagram refers to the activities done by the senior at home, which are inferred based on the data entry obtained from the sensor. This is the system architecture diagram of the application. There are 3 main components. The first component is the front-end mobile application, which is developed using Unity. The second component is the front-end web application, developed using HTML5, CSS3, and JavaScript. This front-end web application refers to the administration portal that I have mentioned earlier. These 2 client-side components will react with the third component, which is the back-end server. The back-end server is developed using Django and deployed on AWS EC2 instance. The database used is the MySQL, deployed on AWS RDS. The file storage used is the AWS S3 bucket. In this project, the main focus will be on these 2 components, which is the front-end web application and the back-end server. Now, I'll talk about implementation. There are a total of 45 back-end REST APIs developed in the application. The distribution of these APIs based on their Django app type is as shown in the pie chart. For example, there's a total of 18 REST APIs developed under the user app. The figure on the right shows the list of APIs developed for the application. These APIs will be called by the front-end mobile application when the user performs an action or request. So for example, when the users interact with each other in the front-end memory function, the front-end mobile application will call these 4 lines of APIs in the red bounded square to retrieve and update the memory details, comments, and the reactions. Now, I will show a quick demo on the administration portal. This is the login page of the administration portal. Only a super user can log into this administration portal. When the admin log in, the admin can view the list of caregivers and seniors that have registered for the application. The admin can also manually add a new user using this button. To view the details of the senior or the caregiver, the admin can click on the action button. For example, now let's click on the test senior form. As you can see, the details of the test senior form is populated here. The list of caregivers associated with this senior is also shown here in this table. The admin can also view the events, memories created under this particular senior. The admin can also view the activities done by the senior at home. The activities are recorded in this timeline records table. The admin can also visualize these activities in a timeline form. Now let's go to the sensor page. In this sensor page, the admin can view the details of the house, the details of the rooms in the house, and the details of the room sensors installed in the rooms. The admin can also visualize the distribution of the number of room sensors based on the rooms they are installed in or based on their sensor type. Now let's go to the analysis page. By default, this analysis page is showing the sensor data for today. Currently, it's showing no data available because all the sensors have been removed in this test senior form house. There are a total of 7 types of sensor available, which is humidity, temperature, light, motion, noise, battery, and TV. Now let me select a date with some sensor data. For example, I pick February 27. Now, the data are populated in the line chart. As you can see, the motion and TV is showing no data available. This means that in this room, there are no TV or motion sensor installed. The admin can also view the data for other rooms. That's all for my sharing in this demo. In conclusion, this application allows the caregivers to monitor the seniors' activity at home without invading their privacy, as well as to provide help in the case of emergency. This application also allows the caregivers and the senior to interact with each other. That's all that I would like to share in this video. Thanks for watching.